So next number, 41. No? So again, so dito, so meron, again, so remember for a 3-core cable, so nasa discussion naman ninyo to sa power system, okay? So again, so ganito yung lalabas na equivalent circuit natin in terms of capacitance, okay? So we have the capacitance to neutral, diba? Okay? So tapos base dun sa discussion natin last time, okay? So kasi yung tanong sa atin, yung nakalagay sa atin dito is, okay? The capacitance between any two conductors, diba? So again, so dun sa discussion natin, ganyan din yung given, so sa power system. So again, ang ibig sabihin niyan is yung nakikita natin na capacitance, diba, as viewed mula dito sa open circuit. So as viewed from two of the conductors, diba? So ng system natin. So ito yung given sa atin sa terminal capacitance, okay? Nakabasa din, makikita natin na this is just given by, okay, so again, series combination ng dalawang capacitance natin. So that's why, so again, so this capacitance is given by Cn divided by 2. So yung capacitance to neutral natin is 2 multiplied by the terminal capacitance. That's 2 microfarad from the given. So this will be 4 microfarad. No? So then what's the charging current? Okay, so again, this is given by, so the line to neutral voltage, kasi to neutral to, so line to neutral voltage yung kailangan natin. I-divide lang natin ng capacitive reactance. Diba? So that's why this will become 2 pi f, so times the capacitance to neutral times the line to neutral voltage. Okay? So this will be 2 pi multiplied by, so from the given, so frequency is 50 Hz. So again, micro means 10 to the negative 6. Diba? So and yung voltage na given sa atin is 11 kilo. So kilo means 1,000. Diba? Divide this by square root of 3. Okay? So this quantity, okay? So then pag sinolve nyo to, makukuha nyo dito yung 7.98 amps. Okay? So this is letter A. Next number, 42. No? Impurities in an electrolyte can cause an internal short circuit condition called, okay? So ito yung number 42 natin. So again, this is what we call the local action. Okay? So this is letter C. So local action. Okay? So next number, 43. No? So number 43, yung tanong sa atin is the fourth harmonic of 800 kilohertz. Okay? Okay? So again, pagdating sa harmonics, again, harmonics are multiples of the fundamental frequency. Okay? Nakaba? So that's why pag fourth harmonic, that's f sub 4. So this is given by 4 multiplied by the fundamental frequency. Diba? So again, so kung ano yung hinahanap natin, kung ano to, kung pang ilang harmonic siya, yun yung minomultiply natin sa fundamental frequency natin. Okay? So again, so this is our fundamental frequency. So fundamental. Pag sinabi natin fundamental, so again, basically this is our operating frequency. So kaya sa problem natin, yung given sa atin na 800 kilohertz, yan ang mismo yung i-assume natin na fundamental, diba? So ibig sabihin sa this will be given by 4 multiplied by 800 kilohertz. So kaya convert natin sa mega kasi magme-megahertz na to. So we have 1,000 kilohertz per megahertz, okay? So then you will get this is 3.2 megahertz. Okay? Okay ba? So kaya again, so dun sa choices natin, troubleshoot nyo lang ito. Diba? So again, yun yung troubleshoot natin. Dapat megahertz yun, hindi kilohertz. Diba? Isa rin yan sa mga common na troubleshoot natin pagdating sa unit. Yung sa unit, diba? Okay? Minsan merong ganyan na discrepancy. Diba? So, nagmo-move yung unit. So instead ng kilohertz, megahertz. No? Instead ng megahertz, kilohertz, okay? Instead of tera, nagiging giga, nagiging penta, diba? And so on. Okay, so again, so yan. So kaya tandaan nyo yan. Madalas yan pagdating sa ET. Okay? Next number, 44. Okay? So again, nakalagay dito, diba? So can hear while talking. So ibig sabihin yung transmission, diba? Saka yung receipt, di ba? Yung pag-receive, di ba? Yung transmitting saka receiving, nangyayari siya at the same time. Diba? So therefore, this is full duplex. No? Yung half duplex kasi, sa akin, so yun ay one at a time lang. Either transmitting ka lang or receiving. Okay? Pero pag nangyayari at the same time, so that's full duplex. Parang telephone. Diba? Okay? Number 45. Sa number 45, so given tayo ng positive sequence saka negative sequence. Correct? Diba? So remember sa lecture natin, so yung IA1 saka IA2 are our references. Kaya ito na mismo yung ating I1. Diba? So yan na mismo yung ating I1. So then ito na mismo yung ating I2. So ito na mismo yung ating I2. Okay? So now, then we are also given this one, which is the current through the neutral conductor. So this is our neutral current. Diba? So which is alam natin as 3 times the zero sequence current. Diba? So for the zero sequence is just given by the neutral current divided by 3. Okay? Naka ba? So kaya so following that, okay, so akin saan equal yung ating phase B current. Ito yung hinahanap. Diba? So mula sa lecture natin, so AC circuits part 2, this should be equal to I0, diba? So plus A squared I1 plus AI2. Okay? And again, so this is 1/3 lang so nung neutral current. Diba? So this is the neutral current divided by 3. So kaya this will be 300 angle. Okay? 300 angle negative 60 degrees. No? So this is divided by 3. Okay? So plus A squared. So 1 angle 240. Diba? So multiplied by I1. So again, so I1 is 200 angle 0 degrees. Okay? So then plus, so again, A is 1 angle 120. Diba? So then multiply this by I2. Diba? So again, yung I2 na gagamitin natin is yung 100 angle 60 degrees. So again, this will be in amperes. Okay? So if you try to solve this, what you will get sa calculator is 200 angle negative 120 degrees. Diba? So again, so wala to sa choices, pero okay lang. So kasi iba yung formula nasa choices natin. Diba? So ang gawin nyo lang dito, drawing nyo lang sa phasor diagram. Diba? So again, so nandito yung angle, 120. So again, that's negative, therefore that's in the clockwise direction. Okay? Okay ba? So then, so ang kailangan lang natin gawin, ilipat siya dun sa positive direction. So kung 120 to, dapat ito ay 240 degrees. So this will be 240 degrees. So therefore, this is also equal to 300 angle 240 degree amperes. Diba? So again, so this is letter C. Okay? So next number, 46. No? So number 46, diba? So again, note that this given 500 MCM is area ng 37 strands. Okay? So isa para makuha mo yung area per strand, i-divide lang natin yung 500 MCM by 37. Okay? Nakuha ba? Tapos yung tanong sa atin is the diameter in mils. So therefore, gagamitin lang natin yung formula. So again, area in circular mil is equal to the diameter squared. Okay? So to solve for the diameter is equal to the square root. Diba? So of. Okay, so area in circular mils. Diba? And again, so saan equal yung area in circular mils? That's yung 500 MCM. What is MCM? Mil circular mil. So that's 1,000 circular mil. Okay? So this is divided by 37 strands. So again, so this will be in mils. So you will get 116.25 mils. Okay? So kaya yung sagot natin dito is letter A. Okay? So next number 47. No. Okay? So number 47, okay? Given tayo ng inductances, diba? So pero since wala sa atin binigay ng mutual inductance, ibig sabihin, so we will assume that the mutual inductance is negligible. So kaya gagamitin natin dito na equation is 1 over the total inductance. So pare-pareho naman yung given sa atin ng inductance. So gawin ko na lang L. No. So therefore, our total inductance is the individual inductance divided by 3. Kasi 3 over L, sa reciprocal, that's L over 3. Okay? So we have 90 millihenry divided by 3. So you will get 30 millihenry. Diba? So this is letter B. Okay? No? Next, number 48. Okay? So number 48, diba? So yung tatandaan natin dito is pagdating sa mga distances. So, sa interior lighting, diba? So again, so meron tayong tinatawag na low bay. So low bay is 12 to 20 feet, diba? So yung mounting height. Okay? So then meron tayong tinatawag na high bay. No? So yung high bay naman natin so is 20 to 45 feet. Okay? Tama ba? So yan. So kaya dito sa problem natin ito sa number 48. Okay? Sa akin itong HID. Okay? So this is a high intensity discharge, no? So tapos we have the high pressure sodium. So this is types of lamps. Diba? So ang pagkakaiba ng dalawang to, diba, is yung sa paraan nila ng pag-produce ng light. Okay? Okay ba? So itong high bay, so again, so ito yung isa sa mga interior lightings natin. Yung high mass naman, this is an exterior lighting. Diba? So this is 45 feet up to 120 feet. No? So this is up to 120 feet. Okay? Diba ba? Kaya so this is exterior lighting. Okay? Diba ba? So kaya siya mast. Diba? So okay, so parang sa mga pole. Okay? Diba ba? So as compared sa bay. Diba? So which is interior. Okay? Diba ba? So kaya dito, dun pa lang sa fact na interior lighting to, sala natin sagot dito sa highway. Okay? And again, so kung isasama natin yung sa definition, diba? So yung 7.6 meters, pasok yan doon sa 20 to 35 feet. Ano ba yung 7.6 meters? Okay? So 7.6, pag kinonvert ko sa feet, that's 3.28 feet. Diba? So pasok to dun sa 20 to 45. Okay? Diba? So kaya alam natin, so this is high bay. Okay? So this is letter B. Next, 49. Diba? So we have, which of the following produces a reactive power? Diba? So alin daw dito yung nagpo-produce ng reactive power? Okay? So again, so dito, okay? So ang magpo-produce lang ng reactive power is pag meron kang inductive element or capacitive element. Diba? So again, so we know incandescent lamp is purely resistive. Diba? Flat iron is purely resistive. Heater, purely resistive. Diba? So obviously, induction motor is a series RL. Diba? So this is an RL circuit. So meron siyang inductance kasi meron siyang coil. Kaya yung sagot natin dito is letter B. Diba? So we have induction motor. Okay? So this is letter B. Okay? Next, number 50. Okay? So yung number 50 naman natin sa is a series RC. Okay? Hinahanap yung time constant. So, okay, so remember, time constant ng series RC is RC. Okay? So okay, this will be given by 1,000 ohm multiplied by 100 micros. Again, micro means 10 to the negative 6. So again, so ibig sabihin, this will be, so this is farad. Okay? So this will be 0.1 seconds. Okay? So kaya yung sagot natin dito is letter C. Okay? So next, number 51. No? So number 51, so a body at rest in a system is capable of doing work. Diba? So if, okay, so syempre magiging capable siya in doing work. So if your body is at rest, pag mag-move lang siya. So kasi kailangan natin ng displacement, diba? So for the work. Okay, nakabasa yung tanong na lang ang tanong na lang dito is again, so saan yung direction or ano yung kumbaga freedom niya, diba? So to move. Okay, nakaba? So again, so syempre this is not to decrease kinetic energy, diba? Mali yung letter C. So again, so we need the potential to move. Okay, nakaba? So alam natin mali yung letter C. Okay, nakaba? So if the potential energy is negative or positive naman, so again, so it does not relate to the capability of the body to do some work. Diba? So kaya alam natin mali din tong A and B. Okay? So letter D lang yung tama. So kasi, okay? So again, so there's a possibility to decrease the potential energy of the system. Okay? Kasi that body is at rest. Meron yung potential energy. Diba? So ibig sabihin, magagawa lang siya ng work if yung potential energy natin so changes in the negative direction. So ibig sabihin, that's the decrease the potential energy of that system. Okay? Tama ba? Sa akin, hindi pwede yung decrease kinetic energy kasi this is at rest. So kung at rest na siya, diba? Sa akin, yung only chance niya for the work is to increase the kinetic energy. Diba? So, pero kaya, so that's not the case. Diba? Kasi ang nakalagay kasi dito is decrease. So, kaya mali yung letter C. So, kaya possible na sagot lang natin is letter D. Okay? So, this is letter D. Next number, 52. Okay? So, a force on a particle is conservative, so F blank. Diba? So, pag sinabi natin conservative, so ibig sabihin, diba? So, pag sinabi natin non-conservative yung force, yan yung work done natin na ini-integrate. Okay? Tama ba? Pag hindi na natin siya kailangang integrate, so ibig sabihin, we are just considering yung dalawang points dun sa system. Okay? Tama ba? Sa akin, so parang kinetic energy sa potential energy. Okay? So kaya yung sagot natin dito is letter D. It work depends on the endpoints of every motion, not on the path. Kasi pag sa path, yun yung kailangan natin i-integrate. Diba? So yung mga ginagawa natin sa thermodynamics. Okay? So kaya yung sagot natin sa number 52 is letter D as well. Okay, so next number, 53. No? Okay, so total negative charge on the electrons of 1 kilogram helium, atomic number 2, molar mass 4. Okay, ang kailangan natin makuha is the total charge. Okay, so therefore, let's start with the given, so which is 1 kilogram of helium. So gagamit lang ako ng concept ng stoichiometry. Diba? So first conversion, so we have 1,000 grams of helium for every kilogram of helium. Okay? So pangalawa, so we know the molecular mass is 4. So isipin that's 4 grams per mole. Ibig sabihin 1 mole of helium contains 4 grams of helium. Okay? Naka ba? And by Avogadro's law, diba? So alam natin, okay? So na each mole is containing 6.022, diba? So times 10 to the 23, okay? So particles per mole. And this is helium atom. So ibig sabihin, atoms yung particles natin. Okay? So we have 6.022 times 10 to the 23. So again, this is atoms of helium. So for every mole of helium. Diba? So ito na yung number of atoms natin. Okay? So then, so sa isang atom, ilan yung electrons? Diba? So again, the atomic number is 2. So therefore, the number of protons is 2. So para maging neutrally charged yung helium natin, so dapat yung number of electron equals the number of proton. So meaning we have 2 electrons, diba? So for 1 atom of helium. Okay, naka ba? And for each electron, the charge is 1.6 times 10 to the negative 19 coulombs. So this is per electron. Okay? So this will be the charge of 1 kilogram of helium. Okay? So this is 4.8. So times 10 to the 7. So again, so this will be in coulombs. Okay? So this is letter C. Okay? So any questions? Diba? So for 53. Okay? 54. Okay? So dito coulombs lo lang. Diba? So ang given sa atin yung dalawang charge, hinahanap yung electrostatic force on the positive charge. Okay? So then, so we are given 2 charges. So isang positive charge, that's 5 coulombs. Isang negative charge, that's negative 2 coulombs. So they are separated by 10 meters. So yung tanong sa atin is the force. Diba? So again, so on the positive charge. So therefore, let's analyze the positive charge. What's the direction of the force? Diba? Towards the negative charge. Diba? So kasi this is, unlike signs, diba? So they are, unlike signs, attracts, diba? So kaya ibig sabihin sa papunta dun sa negative charge yung force natin. So since alam na natin yung direction, magnitude na lang yung kulang, so gagamit lang tayo ng coulombs lang. So force is given by, so 1 over 4 pi. So walang sinabi tungkol sa medium or sa dielectric, so let's assume air. So kaya epsilon naught lang. So then we have Q1, Q2 over D squared. Okay? So then this will be given by, so 1 over, so this is 4 pi. So 8.854, so times 10 to the negative 12, so this will be in farad per meter. So then this is, okay, multiplied by, so again, so Q1, okay, So again, so yung charge na gagamitin natin yung magnitude na lang kasi alam na natin yung direction. Okay, so this is 2 coulombs, so then divided by, so we have 10 meters, so this quantity squared. Okay, so pag tinry nyo isolve, lalabas dito is 9.0 times 10 to the 8. So this will be in Newton. Diba? So 10 to the 8. Okay, so this is letter A. So next, number 55. A certain physics textbook shows a region of space in which two electric field lines cross each other. We conclude that, so gaya na sabi ko sa inyo kanina, magnetic field lines or electric field lines, they will never cross each other. Diba? So therefore, the author made a mistake. Diba? Okay? So this is letter. Okay? Number 56. Okay? So dito given tayo ng potential difference sa charge, hinahanap yung work done in moving the charge across the potential difference. So again, work done is simply charge times the voltage. So we have 2 coulombs by 100 volts. So this is equal to 200 joules. Okay? So this is letter A. No? Number 57. Okay? So again, so an electron is accelerated from rest to a potential difference speed. So the final speed is proportional to blank, diba? Since the electron is accelerated, ibig sabihin nag-increase yung kinetic energy nito, diba? And the increase in kinetic energy, diba? So should be dahil dun sa pagbabago ng potential energy natin sa electrical, diba? The electrical potential energy. So this is our electrical potential energy. So yung increase sa kinetic energy natin, so dahil doon sa decrease ng potential energy sa electrical natin. Okay? So again, so then what's delta KE? Diba? So again, that's 1/2 m times V squared. So remember, it started from rest. So therefore, the initial kinetic energy is 0. Diba? Change in potential energy, this is charge times the voltage. So again, so let's assume that the final potential energy is 0. Diba? So baga lahat ng potential energy natin na-convert sa kinetic energy. So therefore, the velocity will be given by charge times the voltage over mass. So then get the square root. So times 2 pa. Diba? But again, so since this is an electron, diba? So alam natin so na yung charge saka yung mass should be constant. Okay? So ibig sabihin, so the velocity is directly proportional to the square root of the voltage. Okay? So kaya sagot natin dito ay letter C. Okay? So any questions? Okay, so number 57. Okay. Saglit lang na. Okay, so let's continue. So next, number 58. Okay. So number 58, so meron tayong parallel capacitor, isang 2 micro, isang 1 micro. So hinahanap yung relation between the charge or the potential difference, di ba? So now note that since they are connected in parallel, so alam natin pareho sila ng potential difference. Kaya alam natin, so charge yung sagot dito. So either yung letter A or letter B. So check natin kung ano yung mangyayari dun sa charge. Okay? So again, so we have 2 parallel capacitors, di ba? So again, so let's say these are our capacitors. So let's call this a C1. Let's call this a C2. Okay? Okay? So then, okay, so nag-apply daw tayo ng potential difference dito. So let's say V. Okay, so then alam natin pareho sila ng potential difference. Okay? So therefore, if we get the ratio between their charges, remember the charge in a capacitor is given by the capacitance multiplied by the voltage. Pero since equal yung voltage nila since parallel connection, so then ganito yung kalalabasan. Okay? So therefore, if we get the charge in Q2, so ano yung Q2 natin? Ang kailangan kasi natin dito is yung nasa 2 microfarad capacitor. So ibig sabihin, so let's assume na yung Q2, diba, is for the 2 microfarad capacitor. So kung ito ay para sa 2 microfarad capacitor, then yung C2 is 2 microfarad, yung C1 ay 1 microfarad. So then multiply this by Q1. So makikita natin dito na, so yung Q2 is doble ng Q1. So therefore, this is twice. Diba? So we have letter A. Okay? So again, twice. Yeah. So twice. Now, next, number 59. So we have a 60 watt light bulb carries a current of 0.5 amperes. So total charge passing through it in 1 hour is blank. So dito pag tinry nyo itong isolve, normally walang lalabas sa choices. No? So meron ditong troubleshoot. Okay, so yung 0.5 amps, dapat ay 1 ampere. Okay, okay? So then, diba? So pag ginawa natin yan, so then what will be our charge? Diba? So again, that's current times time lang. So kaya this is 1 ampere. So then what's the time? So again, so if we assume 1 hour, that's 3,600 seconds. Okay? So we get 3,600 coulombs. Okay, so this is letter B. No? So medyo malabo lang yung troubleshoot kasi medyo malayo. Diba? So pero normal yan pagdating sa board exam. Diba? Kailangan mo talagang i-exhaust yung mga possibilities. No? Okay? Number 60, diba? You wish to triple the rate of energy dissipation in a heating device. To do this, you could triple the blank. So again, rate of energy dissipation. What is the rate of energy dissipation? Diba? So this is just power. Diba? So kaya pwede natin gamitin is I squared R. Diba? So or V squared over R. So heating device, so sabihin alam natin purely resistive. Diba? Kaya kung isa-isayin natin yung choices, for letter A, potential difference keeping the resistance the same. Pag tinriply natin yung voltage dito, diba? So if we let this constant, tapos tinriply natin tong voltage na to, so then 3 squared is 9. So therefore, the rate of energy dissipation will be multiplied by 9. Kaya mali yung letter A. Diba? Yung letter B, the current, keeping the resistance the same. Pag tinriply natin yung current, so ganun din to actually. Pag tinriply natin yung current, so letting our resistance constant, so 3 squared is 9. So therefore, the rate of energy dissipation will be multiplied by 9. Diba? So letter C, the resistance keeping the potential difference the same. So again, if this is constant, tapos tinriply natin to, so then, mamumultiply yung energy dissipation by 1 over 3. Diba? So ibig sabihin, mali din yung letter C. Yung letter D, the resistance keeping the current the same. If this is constant, tapos tinriply natin yung R, so then matitriple din yung rate of energy dissipation. So therefore, the answer here is letter D. Okay? Next, sa 61, diba? Meron tayong ammeter, gusto nating i-increase yung range from 50 milliamps to 5 amperes, diba? So therefore, ang gagawin natin, magko-connect tayo ng resistance in parallel, diba? And remember, diba? So again, if we want a larger multiplier, yung internal resistance natin dapat mas malaki compared dun sa i-connect natin na shunt resistance, diba? And again, so the higher multiplier we want, the lower the shunt resistance will be, diba? So kaya alam natin, so definitely dito dapat yung gagamitin natin resistance mas maliit sa internal resistance, which is given sa atin as 1 ohm. Okay? So ganito yung given sa atin na internal resistance. And looking at the choices, isa lang dyan yung given na merong parallel resistance na mas maliit sa 1 ohm. That's letter D. Okay? So alam natin yan yung sagot natin sa problem. So pero again, so let's try to solve this one. So meron naman tayong direct formula, diba? So from your discussions, sa DC circuits part 3. Okay? Tama ba? So again, for ammeter, okay? So the multiplier for an ammeter is given by, so this is the internal resistance divided by the shunt resistance plus 1. Okay? Tama ba? So therefore, the shunt resistance, diba? So will be given by the internal resistance divided by the multiplier minus 1. So again, the internal resistance is 1 ohm. So this is 1 ohm. So what's the multiplier? So again, so we want from 50 milliamps to 5 amperes. So this will be 5 amperes, so then divided by 50 milli. Milli means 10 to the negative 3. So para mag-cancel to. So then minus 1. Okay, so if you try to solve this, you will get 1 over 99 ohm. And again, so this is connected in parallel. Diba? So kaya yung sagot natin dito, again, is letter. Diba? So pareho lang nung hinulaan natin kanina. Diba? Kasi nga imposible na mas malaki or bihira kang magagamit ng mas malaking mas malaking shunt resistance ha? Internal resistance kasi hindi naman ganun kalaki yung multiplier mo, di ba? Kumbaga sayang lang yung pag-extend natin ng range. No? Okay? So next, number 62, no? Okay? So meron tayong charging process, di ba? So again, so for a series RC circuit, no? So at the end of 10 milliseconds, the charge is half the final value. The capacitance is about lang. So, okay, so since walang binanggit tungkol sa initial charge, let's assume an initially uncharged capacitor. Diba? So again, number 62. From electrical transient, diba? So 4. Okay? So initially uncharged, okay? Series RC. Second, initiation. DC initiation. Yeah. So we have DC initiation, diba? So again, so alam natin so that the charge is given by, okay, so this is the steady state value, diba? So times 1 minus E raised to negative T over the time constant, so again, resistance times that capacitance, diba? So nasabi sa problem, so at T is equal to 10 milliseconds, no? So yung charge daw natin nangalahati, diba? Nung final value, nung steady state value, okay? So kaya this will be 1 minus E, so raised to negative 10 milliseconds. Again, milli means negative 10 to the negative 3. So then divided by the resistance, that's given as 720 ohm. So tapos multiply this by the capacitance. Okay? So again, ang gusto natin i-solve dito is yung capacitance. Diba? So you can use shift solve or you can just rearrange the equation. Pag sinolve yung capacitance dito, lalabas ay 2 times 10 to the negative 5 or 20 microfarads. Okay? So therefore, the answer for this problem is letter C. Okay? So next, number 63. No? So a magnetic field exerts a force on a charged particle. Diba? So for number 63, if you are familiar with the Lorentz force, no? Okay? So yung maganda sa Lorentz force kasi is magagamit ito for both electric field and magnetic field. Okay? Sa electric field, so we have QE. Sa magnetic field naman, so we have QV cross B. Okay? Nakaba? So kaya yung sa, remember yung sa electric field kanina, di ba? Newton per coulomb. Di ba? Kasi charge times electric field is the force. Okay? So dito tayo magpo-focus sa magnetic field. Okay? So makikita natin na hindi lagi merong force sa magnetic field. Kasi if the velocity is 0, pag wala kang motion, di ba? So again, if this is 0, so pag wala kang motion, wala kang force. So sabihin, hindi always. Diba? Hindi rin never. Diba? So kasi alam natin na pag may value yung velocity mo, and may value yung cross product natin, so then ibig sabihin, so meron kang force. Diba? So ngayon letter A sa letter B, mali na yun yung always sa never. Ang pamimilian na lang natin is yung direction niya kung across the magnetic field or along the magnetic field. Diba? And you can imagine, pag along the magnetic field, so they will be in the same direction. Pag nasa the same direction sila, the cross product is 0. Diba? Pero pag across the magnetic field, so meron diyang angle, so ibig sabihin meron diyang cross product na lalabas. Diba? So kaya ibig sabihin, diba, yung sagot natin is across the magnetic field. No? Okay? So we have this. If the particle is moving across the field lengths. So that's letter C. Okay? So next, number 64. Right? So we have two long parallel lines. So yung number 64. Okay? So which carry equal current in the opposite direction. So equal current so means if they produce the same magnetic field in opposite direction, that will cancel out. Okay? So at a point midway between the wires, so the magnetic field they produce is blank. Diba? So okay, so this is the line midway between the wires. Diba? So okay, so let's assume so that this is, okay, so again, so one of the magnetic fields. Okay? So then the other magnetic field, diba, so should be in the opposite direction. So let's say we have this one. Okay? So okay, gagamit lang kayo ng right-hand rule dito. Diba? So pag nag-right-hand rule kayo dito, diba, so you will imagine or you will see that the direction of the magnetic field in this red wire or in this red line, so again, so it's just given by this. Okay? So kaya ibig sabihin yung direction natin dito should be downward. Okay? Nakaba? So while for the yellow current natin, so again, so using right-hand rule, so again, the direction of the magnetic field will be in this direction. So therefore, doon sa pinakagitna, this is also downward. Okay? Nakaba? So ibig sabihin, hindi sila magka-cancel. Mag-a-add sila. They are in the same direction. Diba? So kaya ibig sabihin, yung sagot natin dito is non-zero. And as you can see the direction, diba? So yung direction niya is perpendicular dun sa plane containing the wire. Ito yung plane natin containing the wire. Diba? So they are perpendicular to that. Okay? So kaya yung sagot natin dito is letter B. No? Okay? So next, number 65. So we have an ideal solenoid. To generate an EMF of 2 volts, the current should change at the rate of blank. Now, so remember, so again, so the direct formula for that, EMF induced in an inductor. So again, this is negative LDI dt. So therefore, solving for di dt, diba? So what will be our induced EMF? Okay. So that is 20 volts. Okay. 2 volts, diba? So again, 2 volts. So divide this by the inductance. Ang given sa atin na inductance is 4 millihenry. So this is 4 times 10 to the negative 3 Henry. Okay? So pag sinolve natin to, so again, so this is given by 500. Okay? Negative 500. Okay? Amperes per second. Pero yung kailangan lang naman natin is the magnitude. So we have this. Okay? So therefore, so the answer is letter B. So yung tanong lang kasi sa atin is the rate of change. Diba? So hindi naman sa atin sinabi kung increasing or decreasing. This one is decreasing. So dapat decreasing siya at the rate of 500 amperes per second. Diba? So, pero again, so dito wala naman sinabi. So kaya pwede magnitude lang ito. Tukoy niya. So we have 500 amperes per second. So choose letter B. Okay? So any questions, number 65? Okay? Okay? So submit lang ulit. Okay? So next, number 66. No? So number 66. Okay, so this is, I think, electrical transients again. No? So we have 8 millihenry inductor and 2 ohm resistor are wired in series to a 20 volt ideal battery. So this is series RL circuit. Diba? So as we see, the circuit is closed at time t is equal to 0. At which time the current is 0. So after a long time, the current in the resistor and the current in the inductor are blank. No? Okay? So again, so this is series RL. Okay, so we have RL. No. L. Okay, so this is R, this is L. Diba? So then this is our battery. Okay? So this is, let's say, our EMF E. So then so let's say this is the switch which is closed at t is equal to 0. So again, so then the current will flow. Diba? So yung tanong sa atin is after a very long time. So it's in steady state. So again, at steady state, remember that the inductor is a short circuit. So therefore, our current I, so will just be given by E over R. So again, from the given that is 20 volts and 2 ohms. Okay? So you will get that this is 10 amperes. Diba? So pero remember, even though short-circuited yung inductor, nandyan pa rin yung inductor natin. So kaya ibig sabihin itong current na to, this is the resistor current as well as the inductor current. Okay? Sagot natin dito is 10 ampere, 10 ampere. Diba? So again, the current through the resistor and the current through the inductor. Diba? So this is letter A. Okay? So, hindi ko pala nailagay ito kanina. Number 61 is letter D. No. Okay? Okay? So next, number 67. No? So again, 67, if both the resistance and the inductance in an LR series circuit are doubled, the new inductive time constant will be. So series RL lang to. Diba? So again, so for series RL, time constant is L over R. Diba? So again, in the case na na-double yung ating inductance sa resistance, tawagin natin to as our T2, tau 2, diba? So again, so our second time constant. So again, na-double daw yung inductance, na-double din yung resistance. So as you can see, this is just equal to the original time constant. Okay? So that's why this is unchanged. Diba? So yung sagot natin dito is unchanged. Okay. So again, ang sagot natin dito is unchanged. No. Okay? So this is letter D. Okay? So next, number 68. No? So again, so stored energy in an inductor. What is the stored energy in an inductor? This is 1/2 Li squared. Diba? So kung iisa-isay natin yung choices, diba? The stored energy. So letter A depends in sign upon the direction of the current. That's not true, diba? So kasi, so again, so yung current natin dito, whether positive or negative, the energy is positive. So it doesn't matter kung ano yung direction ng current, diba? Okay? So letter B depends on the rate of change of current, not true. Walang rate of change ng current, so dun sa equation natin. So rate of change ng current is di dt. Walang di dt sa given, diba? Or dun sa equation natin. So letter C, proportional to the square of the inductance, also false. Kasi inductance lang, hindi square ng inductance. Diba? So letter D, none of the above. So this is our answer, none of this. So we have letter D. Okay? So next number, 69. Okay? So we desire to make an LC circuit that oscillates at 100 Hz using an inductance of 2.5 Henry. So we also need the capacitance of. So guys, remember, so na yung frequency, diba? So of an LC oscillator is the same as the frequency in resonant frequency. Diba? So this will be square root of LC. Okay? Tama ba? So which means, okay, so that our capacitance is given by 1 over. So again, frequency is 2 pi f squared, so times the inductance L. Diba? From the given, okay, so ano yung given sa atin na frequency dyan? So again, so this is 69. So we have 100 Hertz. So again, so this quantity squared. So then multiply this by the inductance L. Okay? So which is 2.5 Henry. Okay? Pag sinolve nyo ito, lalabas dito 1 times 10 to the 6 or 1 microfarad. Okay? So this is letters. Okay? So number 70, diba? So yung tanong sa atin is, the impedance of an RLC series circuit is definitely increased if blank. Diba? So saan ba equal yung impedance natin? That should be equal to square root of, okay? So we have R squared plus, okay? So this is X sub L minus X sub C squared. Diba? Again, kung isa-isay natin yung choices, again, so yung gusto natin mangyari is kahit anong mangyari, diba? So the impedance will increase. Diba? So for letter A nakalagay, C decreases. Diba? If the capacitance decreases, so it means the capacitive reactance increases. Diba? And again, so yung problema dito is if, okay, so X sub L is greater than X sub C. Diba? So then X sub L minus X sub C decreases. Diba? So if this decreases, then the impedance decreases. Diba? So kaya mali yung letter A. Okay? So next letter B. Okay? So for letter B is the inductance increases. Diba? So again, so this means that our inductive reactance also increases. Diba? So again, the problem here is if X sub C is greater than X sub L. Kasi pag nangyari yan, yung X sub L minus X sub C natin, so this decreases in the negative direction. Diba? So therefore, pag in-square natin to, this overall decreases. Diba? So therefore, the impedance also decreases. Diba? So ay mali din yung letter B. So letter C naman, inductance decreases. So then the inductive reactance decreases. Diba? So then, okay, so if X sub C is less than X sub L, diba? So then X sub L decreases. Diba? So ibig sabihin, X sub L minus X sub C. Diba? So again, X sub L minus X sub C. So again, so this decreases in the positive direction. Diba? So kaya ibig sabihin, so this becomes lower, so then this becomes lower as well. Diba? Kaya sagot natin dito, diba? So it's letter D. So for letter D, the resistance increases. And if the resistance increases, no matter what the value of the reactance, diba? So again, so the impedance also increases. So therefore, the answer is letter D. So again, base dun sa equation natin. No? Okay? So next number, 71. Okay? Okay, so following DC generator will be in a position to build up without any residual magnetism. This should be separately excited. So pero base dun sa mga nakalagay sa choices, diba? So ito lang yung possible, diba? So na maging separately excited. So dun sa choices natin. Okay, tama ba? So kaya yung sasagot natin dito is letter D. Okay? The number of armature parallel path in a two-pole DC generator having duplex lock winding, no? This is number 72. Okay, so again, 71 is letter T. So again, so this should be separately excited, pero somehow dun sa libro, self-excited yung nakalagay. So kaya yan yung napalagay dun sa pre-board exam. Diba? So number 72, so again, we have duplex lock. So MP, so yung formula natin. So duplex, number of poles is 2. So then this is equal to 4. Diba? Kaya yung sagot natin dito is letter B. Okay? So next number, 73. Okay? So in a transformer, frictional loss is, I mean, remember sa transformer, walang rotating part, so wala tayong frictional loss. So therefore the answer is nil. Diba? So nil means 0. Okay? So next, 74. Okay? So we have, in an induction motor, P is the power delivered to the rotor. So this is the rotor input. S is the slip. So ano daw yung losses sa copper sa rotor, the rotor copper loss. So again, we have the formula. Rotor copper loss is equal to slip times the rotor input. So hence, this is S times P. Diba? So this is letter B. No? Number 75. Okay. Reflecting mirrors used for exploiting solar energy. So these are called heliostats. No? So blank power plant is expected to have the longest life. So again, so itatandaan nyo dito is yung steam saka diesel, mas malaki yung maintenance cost niyan compared sa hydroelectric. So kaya ibig sabihin nun, diba, is yung hydroelectric natin is easier to maintain. So which means it's possible na mas mahaba yung kanyang expected life, diba? Kaya yung sagot natin dito is, okay, so we have hydroelectric. So which of the following is the demerit of a constant voltage transmission system? So yung sagot dito is increase the short circuit current of the system. Okay? Number 78, 310 kilometers line, diba? So again, so we have heliostats, hydroelectric, increase of short circuit current system, DCA. No? So again, sulat ko muna dito. Okay, so again, this is D, C, A, diba? So number 78. So again, so remember, pag sinabi natin long transmission line, so these are greater than 240 kilometers. So ibang libro 250. So pero regardless, 310 kilometers is a long transmission line. So 310 kilometers is a long transmission line. Diba? So this is letter. Okay, so letter A. Now, 79. Okay. So then we have the most serious result of a major uncleared short circuit fault. This should be fire, diba? In terms of damages, diba? So again, pinakamalaki yung sa fire, diba? Number 80, the first modern, okay, so computer, so is known as, so ito naman yung ENIAC, letter C. Okay, mga ba? So again, so this is fire, letter B, no? Number 8 is ENIAC, letter C. Okay? So any questions? Diba? Sabi so far? Okay?